Welcome to video 3 on gradient boosting in our course B10 Python for AI, a very basic course for people new to this area. We're going to talk gradient boosting, and this, it is worth noting, focuses on structured data. So it can be used to make ensemble methods, and that means that they can apply different models to different data sets, thus leading to divergent solutions, but each solution for each data set should be optimal where possible. And basically, what we're thinking about is that we initially develop a weak model. We extract the residuals from the model, retrain the model with that residuals, and repeat this process iteratively until we get a much more higher confidence model. That means we're starting with a weak model. We get a shallow decision tree. That is the level of branches that differentiate the different options is not very strong. Um, and we look at the residuals from that. So we calculate where the model is wrong, we sum that up, and that could be using something like mean squared error, and get the sums of squares between the differences between the predictions versus the actual values. We then train the tree on the residuals to correct the previous model's mistakes, and repeat that process iteratively until we get a sufficient number of runs that we get a better model. We then add trees scaled by the learning rate. So you repeat this many times, and each tree contributes a small amount controlled by this rate of learning. And this means that weak models can combine into one strong model. There's different libraries that can be used for gradient boosting. XGBoost is probably the most widely used one. It has built-in regularization and handles missing values well. LightGBM is also effective. It can be faster in large data sets. Instead of working across different levels, it works across the different leaves of the tree, and can, in certain situations, outperform XGBoost. CapBoost is another option. It can also handle not just numerical data, but also string data as well. Key parameters are to think about the number of estimators at the start, the learning rate required, and the max depth of the tree. And a lower learning rate and more trees is usually better than fewer trees with a higher learning rate. So you can think of the learning rate as kind of the random walk of trying to find a better solution across some sort of plane where some parts may be better than others. So we want that rate of walking to be at a certain level to find the optimal solution. And we can stop it early to find the optimal number of trees automatically. So what we can ask ourselves is, in gradient boosting, what does each new tree learn to predict? The original target values from scratch, the residuals or errors from the previous trees, a random subset of the training examples, and the average of all the previous predictions. And what we can know from what we went through there, that's not looking at the original, it's not trying to predict the original target values. It's trying to predict based on the residuals of the previous trees. And it's not using a random subset of training examples, and it's not making an average of all previous predictions. So that brings us to the end of this video on gradient boosting. Please see the next video to learn more.